All right, today we're going to talk about solving right triangles. And what that means, when I say solve a right triangle, it means you want to find every single missing piece of it. You want to tell me how long all the sides are, how big all the angles are. There are actually 6 different aspects to this. There are 3 sides, 3 angles, and you want to be able to tell me all of it. Now the good news is you already know how to do each of these steps individually. It's going to take a few different steps to do that, but you already know how to do it. Now, even though there are 6 parts to a triangle, you're never going to have to find more than 3. And let me show you why. So let's say I drew a right triangle right here. And I say, let's solve this triangle. Well, number one, we already know that one of the angles is a right angle. And a right angle is 90 degrees. So that's 90. I don't have to find that one. So automatically I'm down to 5. There's only 5 things left. Well, in order to even be able to do the question, you have to be given some information. So let's say in the problem I tell you that the hypotenuse is 20 and this side on the bottom is 10. Well, that's 2 more things that you don't have to find because you already know. So basically there's going to be the right angle, that's one thing. There's going to be 2 pieces of given information, that's 3 things. You have to find the other 3. So the 3 things I would need to find in this question are, number 1, this side over here. I would have to figure out how long it is. Number 2, this angle over here. And number 3, this angle up here. But remember, like I said on the middle bullet point here, you already know how to do this. I'm not teaching you something new today. We're combining some things we've already learned into one problem. So let's talk about how to do that. First of all, there's a rule for triangles. We've used it a few times this year. It says that the 3 angles of a triangle always add up to 180 degrees. Well, if you have a right triangle and one of them is 90, well, 180 minus 90 is 90. So there's 90 degrees left over for the other 2. That means if you know one of the other 2 angles of a triangle, you can just subtract from 90 to find the last one. So that's going to be super easy. Let me show you a picture again. Let me draw that same right triangle here. So let's say I have a right triangle. We already said right angle is 90. So this means 90 degrees. And let's say, for example, in the question it said that this one was 32 degrees. Well, we know that these 2 together have to be 90 degrees, because 90 plus 90 will give me the 180 total degrees for the triangle. So all I have to do, I don't have to do SOHCAHTOA or inverse trig or Pythagorean theorem. I just go off to the side, I do 90 minus 32, and it comes out to 58. And that's it. The other angle is 58 degrees. It's that simple. And in fact, this is going to happen every single time you do solving a triangle. So remember I said you have to find 3 things. One of them is this easy. It's just subtracting from 90. So really what you're doing is 2 real problems in one. And those problems are going to be the kind of things we've been doing in class. So let's focus on the other 2. Other than subtracting from 90, which is very simple, for the other 2 parts of the triangle, these are the 3 things you might do. You're going to do 2 out of these 3 things, basically. Number 1, you might need to use SOHCAHTOA to find a missing side in the triangle. That's what we did before break and what we reviewed earlier this week. Number 2, you might need to use inverse trig or inverse SOHCAHTOA to find a missing angle. That's what we just learned this week. That's what's new for us. The third possibility, you might use Pythagorean theorem, a squared plus b squared equals c squared. And that's if you look at the triangle and you know, like the first picture I drew for you today when I gave you 2 sides, I said the hypotenuse is 20 and the bottom was 10. You could just do a squared plus b squared equals c squared and find that third side. So depending on what information is given in the question, you're going to need to do 2 things of this list of 3. Each question will be different. Sometimes you might use SOHCAHTOA and inverse trig. Sometimes you might use Pythagorean theorem and inverse trig, or every question's different. You're going to use 2 out of those 3 things. So let's look at an example. and talk about what our choices are. So the example here says solve the triangle, and it has a right triangle, and it has two pieces of information given, two sides, with a side is 4 and a side is 13. So this is the exact setup that I described to you guys. There are three things we need to find here. What I'm going to do, I'm going to pick out those three things right now, and I'm going to assign them variables. I'm going to call them, let's say, X, Y, and Z. So the first thing, and not really first in order, you can do it in any order you want, but the first thing I notice is I need to find the third side, the hypotenuse. So let's call it X. And we're going to need to solve for X. But then I say, well, I also don't know either of the angles. So let's call this angle up here Y, and this one down here Z. And now I have a three-part question where I need to find X, Y, and Z. Now, you can do it in any order. You don't have to find X first, but that's what I'm going to do. I'm going to go ahead and find X first. Now, what I notice here is I don't need to use SOHCAHTOA, because when I give you two sides, we could do Pythagorean theorem, and I think that's a little easier. So let's do that. Let's do a squared plus b squared equals c squared. And this is a Pythagorean theorem review for you guys. This is for right triangles, and just remember that the c has to be the hypotenuse. And in this question, the hypotenuse is x. So I'm going to put the x squared here. And then the 4 and the 13 are a and b, and it doesn't matter which one is which. So let's put 4 squared plus 13 squared. Okay, 4 squared is 16. 13 squared is 169, and you're welcome to use a calculator for this. Add it together and you get 185. Now, take a square root, and we'll have our first answer. We'll have x. So what I'm going to do, I'm going to use a calculator. I'm going to pause the video for a sec. And what we get for x is about 13.6. So I'm going to put that up here. And that's the first part of our answer. Now remember, you have to find three things. We just found one of them. We found x. So now let's find y and z. Now y and z are angles. And when I look at the question, if I want to find an angle in a right triangle, I need to use inverse trig. So if I'm going to use any type of trig, whether it's inverse trig or regular trig, we need to label our sides, opposite, adjacent, and hypotenuse. So in the triangle, the x, or which we just figured out was about 13.6, that's the hypotenuse. Let's pick which angle we're trying to find. It doesn't matter which one you do. Let's do y. So let's say we're going to find angle y. If I'm finding angle y, that makes 13 opposite. Because remember, after you pick the angle that you're talking about, that's how you choose opposite and adjacent. And then that would make the 4 be the adjacent. So let's use the original numbers from the question. Let's use the 4 and the 13. Now from SOHCAHTOA, I'm trying to use O and A. That makes this a tangent question. Now, remember, once you choose sine, cosine, or tangent, after that comes the angle. And the angle, remember, I circled it just to make sure I'd remember. The angle I'm talking about in this question is y. Now, what it equals, now you go back to SOHCAHTOA, OA means opposite over adjacent. That would be 13 over 4. Now, finally, this is what we learned brand new this week. This is the inverse trig part. If it said tangent of a number, like tangent of 20, that's when you just grab a calculator and type. But when it says tangent of a variable, like y, that's when you use inverses. So what I'm going to actually type, I'm going to put y equals, because that's what we're solving for. What I'm going to actually type into the calculator is inverse tangent of 13 over 4. You're still using that same number. You're still using that 13 over 4. But you're going to do an inverse tangent to figure out what it equals. Now I'm going to pause the video and use my calculator again. And it comes out to about 72.9. And that is the second part of your answer, 72.9 degrees. Now, we're almost done with the question. Now, if you remember back from the notes a few minutes ago, I said in every single one of these questions, you're going to have two kind of actual work parts, and that's what you see right now in the green and the purple. One of the three things, don't do that again, because as soon as you know one of the angles, now that I know that that angle is 72.9 degrees, for the last one, all I do is subtract it from 90. Oops. Just do 90 minus 72.3. And that would end up being 17.7. And that's your final answer. That's your last answer. Z here is 17.7 degrees. And see how easy that was? You don't want to do inverse trig again or SOHCAHTOA or Pythagorean theorem. You don't want to do any of that hard work. One out of the three things is always very, very simple. As soon as you know one of the angles in the question, even if it's given, in some of the questions, one angle will be given, then do that first. Just subtract from 90, you got the other. But one out of the three is always very, very simple. The other two are going to be like the work we just did, first in green and then in purple. But that's solving a triangle. You have to find everything. You have to find three things.